Let's do one more. So we can't just take the log base 5 here, because on the other side we have a exponential base 3. So what people then usually do is take a natural log or a common log, and I prefer the natural log. So if I take the natural log of 5 to the power of 2x minus 1, then I have to do the same thing on this side, and that's going to allow me to bring down these exponents. So I can then write 2x minus 1 times ln 5 is x plus 3 times ln 3. Okay, so that didn't seem to help much yet. So let's distribute and see what happens. And I will try to explain a little bit better why we want to do this, because a lot of times we do not want to distribute, but in this case we do. So we get x ln 3 plus 3 ln 3 here. So just make sure you distribute obviously all the parts. Okay, now what we can do is bring everything that has an x, which in this case is this part, and we're going to bring that over to this side. So the way that we do that is to subtract x ln 3. So that's going to cancel over here, and on this side it would give me 2x ln 5 minus, and I'm going to switch that around a little bit, ln 3x. Okay. I would want to sort of do the same thing over here with that ln 5. So I want to add ln 5 to both sides. So I already had 3 ln 3, and I'm going to add ln 5 to that. Got two steps left. I have an x on this one, and I have an x in this term. So that's common. So if you factor that out, then you have isolated your x, which is what we want to do. You want to get that x completely by itself. Well, I haven't quite isolated yet, but I'm going to be able to isolate it and get it completely by itself if I just divide all of this now by this large mess over here. So the final answer will be x is 3 ln 3 plus ln 5, and then divide all of that by 2 ln 5 minus ln 3, and that's the exact answer. If I really wanted to know what that was worth, I would have to get a calculator and I would get an approximation, and that's going to be about 2.31. Now, my preference really is that you provide the exact answer, so that would be the ln answer, and this would be the approximation of that. So sometimes that's needed, but in a lot of times you can just leave that out. So thank you.